artificial neural networks achieve state-of-the-art performances in an ever-growing number of tasks. However, there are problems like the presence of biases in the training data, which question the generalization capability of these models. In this work, we will show a method to address this issue. As a visual example of what a bias in data is, we can think of introducing some background color in the MNIST dataset, which becomes our bias. Or even, targeting age classification with a gender bias. In these cases, how can we prevent our model from learning the biased features rather than the target ones? We propose a regularization strategy which aims to discourage the selection of biased features while also encouraging the selection of the unbiased ones, and we name this technique EnD, from Entangling and Disentangling. Let us identify in our deep model some bottleneck layer gamma, followed by a feature normalization layer. From the normalized representation, we can compute the Gramian matrix on the features, which is the foundation of our regularization strategy. Let us represent the extracted features in an hypersphere. In this example, the bias is represented by the marker color, while the shape represents the target class. Here the model has learned to classify samples based on the bias attributes rather than the target class. To fix this, we have proposed two regularization terms. We have a disentangling term, which discourages the selection of biased features, decorrelating them. And we have an entangling term which favors the extraction of the features having same target but different bias. As a first toy scenario, we work with the biased MNIST dataset, where we have a control parameter, rho, modeling how the bias, which is the background color, correlates to the target, which is the digit value. Typically, for high correlation values, vanilla training makes the models learn the biased features rather than the target ones. However, if we use our proposed EnD strategy, even when the correlation between bias and target is very high, the model learns the correct features. Interestingly, we observe that in the very first epochs, which we name kick in region, the model tends to learn the easiest features, which is the background. Then, EnD regularizes the model, which learns the correct features. Compared to other debiasing strategies, ranging from the GAN-based approaches to direct gradient manipulation, EnD proves its effectiveness especially in the most challenging scenario, where the correlation between target and bias is 0.999. EnD shows a significant gap compared to the other strategies. EnD proves on the field its effectiveness also on other datasets. We have tested EnD on Celeb A and IMDb, training on many features like hair color or the age and using the gender as bias. More details and the ablation study can be found in the paper. The code is open source and publicly available online. Thank you for attending.